right, calculus, I got for you a little video here for just some final velocity help, whether it's for your homework set 4 or getting ready for the exam next week. Here you go. So let's say you've got this equation. It could be s of t, position, or it could be h of t, meaning like the height of an object as it's being shot through the sky. Negative 16 at t squared. That negative 16 is important. That has to do with acceleration, feet per second squared. 112 is the initial velocity, and 41 is the initial height. So you could be given either of those. It could be s of t or h of t. All right, so part A, if it says find the average velocity over the interval t equals 2 to t equals 3, just need to find where is it at, what height is it at time t equals 3, so where you're ending. Plug 3 in for t, get 233. Plug 2 in for t then, where did you begin? You get 201, so the average velocity is where you ended up minus where you began divided by the time it took. So 32 over 1, your average velocity is 32 feet per second. Okay, so that's pretty easy there. Okay, we didn't really do any calculus, we just did, there you go, we got slope there. Difference in where you ended minus where you began. It's very important to do where you ended minus where you began, okay? Because you can have a negative average velocity as you can have a negative instantaneous velocity, as we'll see in this next one. All right, so this part here, find the instantaneous velocity at time t equals 5. So velocity at time t is equal to the limit as h goes to 0 of s of t plus h minus s of t over h. It looks just like the limit definition of a derivative. Instead of having f of x plus h and f of x, we have s, and we're actually going to plug a number in for t. Okay, so s of 5 is actually 201. Notice how s of 2 was 201. Well, if you remember from college algebra, negative b over 2a gives you the vertex, and the vertex is at 3.5, so it reaches its highest, it reaches its maximum height. We can find that too using derivatives soon at time 3.5 seconds. So if you move 1.5 to the left and 1.5 to the right, you're at 2 and 5. Makes sense, we're at the same heights. We get 201 again. Okay, so it hits 201 going up and then coming down. So this is the coming down portion. So what I'm going to do, it's going to be s of 5 plus h minus s of 5. Here you're actually plugging 5 in for t. All right, so velocity at time t equals 5 is the limit as h goes to 0 of s of 5 plus h minus s of 5 all over h. So I'm plugging 5 plus h in for t. There and there, and then this is minus s of 5. Again, I'm plugging 5 plus h in for t in my initial position function. S of t is equal to negative 16t squared plus 112t plus 41. Again, it can be h of t on your exam. Same deal. Velocity is the derivative of the position function. All right, so I'm just doing the algebra here. Okay, distribute the negative 16. This plus this minus this is 400, which is nice because the 400s cancel, as you know. Divide everything by h, and I let h be 0 finally, and I get negative 48 feet per second. It's coming down. All right, so that will be really helpful, obviously, on your homework, but you will have a velocity question on this week's exam. Okay, so pause this, watch this again. It's very important. You are actually plugging whatever time it is, 3, 2.5, you're plugging that in for t. The only other variable that's going to remain is h. So it's going to be whatever you're plugging in plus h. All right, and then you're plugging something in. You get some number there. All right, there it is. I think that should help. All right, we're going to have a good exam next week, and this is Yak Math Videos signing out.